Hey everyone, this is Mr. Fugay, and for today's video, we're going to talk about how to find the area of a sector. At this point, hopefully, you have already learned and talked about how to find the arc length of a circle. So, just as a recap, using pizza as an analogy, when we talk about arc length, we're talking about how much of the crust are we eating on a pizza. So, if I ate the entire pizza, the entire crust, that would be called the circumference. But if I only eat, let's say, one slice of pizza, that piece of the crust is part of that circumference, and we call that the arc length. So we're going to shift gears today, and we are going to talk about how to find the area of part of a circle. And the name of that, we're going to call it, is a sector. Sector meaning a section of the circle. So by definition, a sector is a part of a circle that is created by two radii, plural for radius, and an angle. So if you see over here in the diagram on the right, what I'm going to highlight for you in red, this triangular looking thing with a curved edge, like a slice of pizza, that is considered a sector, okay? Notice that at the center here, we have its central angle. That central angle is going to be crucial in helping us be able to find the area of this sector in a little bit. You also can see that the two sides here are both going to be radii that create that. So a circle can be divided. When you create a sector, it actually divides into two different slices, two different pieces. So the first sector is called the minor sector, and that's going to be the smaller part of the circle. So that's going to be the part here in dark blue. Okay, so that's going to be our minor sector. And then the major sector. So you probably remember talking about minor arcs and major arcs, which are, again, very similar definitions. So this lighter blue area is considered a major sector. So in theory, when we create a sector of a circle, we actually split the area up into these two slices. The part that we're going to focus on in today's lesson is how to find the area of the minor sector, which is going to be this part here formed by the central angle. So very similar to the formula for arc length, the formula for the area of the sector looks as follows. So area of a circle is pi r squared. So this portion of the formula that we're looking at here is that entire area. So the first thing we're going to do is we're going to find the area of the entire circle as if I'm not cutting it up. And then we're going to multiply it by, this is considered the fractional portion of the circle that I want. So we look at the central angle, which is going to be this theta symbol here, and we're going to plug that in, divide it by 360, and that's going to give me the fractional portion that I'm working with. Now, for all intents and purposes, we want to try to write our answer in terms of pi when we're finding area, and you'll see in other examples where we might have to apply decimals to get our answer in our calculator. So let's do a few examples. We're going to start with example number one. Find the area of sector QRS, okay? So let's go ahead and let's write our new formula here. So it's going to be theta over 360 times pi r squared. So there are two things we need to find in this problem. We need to find our theta, and we need to find our r to figure out the sector. So looking down at my diagram, my theta is my central angle, which is going to be 120 degrees, and my radius here is going to be 9. So we're going to go ahead and we're going to plug those values into the formula, and I'm going to denote that in the color blue just so you can see the difference here. So the theta being 120, we're going to plug that in right there. 9 is my radius. We're going to plug that in there. The next move we're going to make in our calculator, and to compute this, is we are going to calculate everything that is not pi, meaning I'm going to put 120 over 360 and 9 squared into my calculator. So let's go ahead and head over there. Regardless of what calculator you're using, you want to hit the fraction button for that. We'll go ahead and put our 120 over 360 in. And if you know how to simplify that, you can certainly simplify it prior to doing this. Just like if you know 9 squared is 81, you can write 81. But nonetheless, when I multiply all that together, I get 27. So my highlighted values there, when I put them together, is going to be 27. So we can't forget that. And the last thing we can't forget is we never multiplied the pi. So the answer here is going to be 27 pi. If there are units for this, it's probably a good habit for us to let's go ahead and label that. So area is a square unit, being that it is a two-dimensional unit. So that is the reason why we're going to say the units here are 27 pi and the units are square inches or inches squared. So take a moment looking at that example, and I would like you now to try example number 2. Please pause the video to try this problem out, and then I will have a solution here in a moment. At this point, hopefully you've tried this problem out. Just like the last problem, we have two variables we need to look for in our diagram. That is our theta, our central angle, and our radius. So our radius is 9, so we have that right there. Now, interestingly enough, they did not provide the direct central angle in this question, but something you want to remember is that the arc measure, this is the arc measure of 40 is the same thing as the central angle from a prior lesson. So that's where we should be gathering the 40 from. So we'll have that plugged in, have that plugged in. Once again, we will put the 40 over 360 times 9 squared in my calculator, and I got 9 as an answer. We'll apply the pi. The units was millimeters, so it's going to be millimeters squared. So scenario number 1, there it is. Find the arc length if you know the area of the sector is if you know the central angle and you know the radius. The second scenario we're going to look at here is what if we know the area of the sector, which in this case is 50 pi, and we know that the angle formed is 110. So in this case, we actually want to find the radius in this problem. So if we set this problem up, once again, let's write that area formula out. It's always nice to have that there. Okay. So in this case, the two things that I know is my area and my theta. We don't know my r squared. So let's go ahead and let's plug those in. So we're going to get 50 pi equals, the theta here is going to be 110 over 360 times pi times r squared. So there's a couple ways to do this, but the easiest way would be probably to get rid of the fraction first, then get rid of the pi second, even though if you notice, the pi's will always cancel here. So if you know that right away, you can essentially divide both sides by pi and they cancel out. So really, I just need to get this 110 over 360 out of the way. So you can either type in divided by that, because we could divide both sides by it, but another way to solve an equation with a fraction is multiplying by the reciprocal. This is a good strategy for algebra when we're solving, because on the right-hand side, those will eliminate. I'm going to move my next step over here because I'm out of space. So in my calculator, we're going to do 360 times 110, 360 over 110. So let's go ahead and do that. So it's going to be 360 over 110. And then we're going to multiply that by 50. Okay, so we get a fractional answer. At this point, if you get these weird improper fractions and a simple answer, a decimal answer, I should say, wouldn't be a bad idea here. I forget how to get decimal answers on this calculator, but I think I go math. If you don't have this calculator, that's no problem. There it is. I have to go to math decimal enter. So it's 163.6. So 163.6. We still have that pi symbol there. We never got rid of that, even though I should be canceling that. In fact, let me go ahead and let's cancel that now because those are gone. They eliminate from there on both sides. So the last thing I need to do is to get r by itself. We're going to take the square root of both sides. So when I do that, we will take the square root of our answer. And we're going to get 12 we'll round that to 12.8. So 12.8 equals our r. They did say square meters, so technically the unit of the radius would be in meters. Okay, so that's number 3. I'm going to go ahead and have you pause this video again, and I want you to try example number 4. I'm only partway through this problem because I wanted to talk about something here that happened that has not happened in our other problems, and that is that the arc or the area of the sector here was not given in terms of pi. It was just given simply as 75. So I went ahead and did my first step. I multiplied both sides by the reciprocal, just like you should have done in the previous example. So I get 771.4, but the problem with this one is I don't get rid of the pi like I did in the last problem. Since there was a pi on both sides, I was able to easily cancel them, but it didn't work here. So what I'm going to have to do as an extra step here is divide both sides by pi. There's a pi button in your calculator. You technically can also use 3.14. When I put that in the calculator, I get 245.7 equals r squared. Now we're back to like the other problem where we can take the square root of both sides. And so 15.7, the units here are inches, is going to be the length of my radius. So scenario number 2, if you know the angle and you know the area, we can find the radius. So the last leg of our lesson here is what happens when we need to find the central angle itself. So here it is. We have the shaded area of the sector as 10 pi. We also know that the radius is 10 kilometers. It's a rather large unit, but we can still do this. So it's going to be theta over 360 times pi r squared. So in this last scenario, we know the area, we know the radius, so we're going to go ahead and plug those things in. Get 10 pi as my area. We're going to leave that theta alone here. And then we get r squared, which is 10 squared. I'm going to go ahead and just call that 100 right off the bat. Okay. Now, right away, there's a couple things we can do here. There's a lot of numbers here. So one of the ways we can do this is I have the 100 pi right here. Okay. If I were to divide both sides by 100 pi, that could be beneficial to me because, again, the pi's will end up canceling. These will end up canceling. 10 over 100, if you put it in your calculator, should give you the fraction 1/10. If you wrote it as 0.1, that would also be okay with me. And now we get the theta over 360. Some of you might go ahead and multiply the 360 as in 1 over 360 times pi times 100 and then do the division. That step is okay too. Remember, at the end of the day, we're just trying to solve this for the variable. So at this step, we have the theta over 360. We'll multiply both sides by 360. Cancel, cancel. And so we're going to end up getting an answer here of 36 degrees, since we're looking at an angle, as my theta. So much like the other two examples, that I did, I'm going to have you pause the video and try the last example on these notes, see what you come up with, and then we will review in a few seconds. Here is our final example of the lesson. So here we go. We have our area of 31 pi. We have our radius of 10, which I already squared here and got 100. So we do the same thing I did in the last problem. I'm going to divide both sides by the pi times 100 or 100 pi, whatever you want to call it. When I do that in my calculator, I'm going to get 0.31. Last step here to get rid of the over 360, we multiply by 360, and we come up with a result of 111.6 degrees. So there are three variables in this formula: the area itself, the theta, which is the central angle, and the radius. And we've now gone through one of each example when one of them is unknown and the other two are known. So these are all the different scenarios you could encounter when working with the area of a sector. So I hope this video was helpful. As always, please don't hesitate to ask me any questions in class or go back and rewind to any portions of this video that you would like to watch again. Thank you for your time and thank you for watching. Hope you have a good rest of your day, guys.